Welcome back everyone to another video on fork join, and this time we are going to use two types of process control that can be paired with fork join to carry out some meaningful task. And those two are wait fork and disable fork. So whenever in the process flow of a SystemVerilog code, a wait fork is encountered, the process of that particular code will wait for all the remainder of the uh, threads to complete first. Then only it will proceed forward. So it will block the program flow. And as per the disable fork, it will just eliminate all the pending process which are or threads which are running in parallel inside the fork join. So whenever it is encountered, it will just eliminate everything. So without any further delay, let's begin with an example. I will write a test module, and inside it, I will use a fork join none. Join none does not wait for any of the threads to complete. So even all these threads starts in parallel, whatever is written after the join none will start executing. So it will not wait for the all the threads to complete. So we will add two threads inside it, and instead of task, we are going to use a simple display system task. So let us use a begin and end for our uh, thread number one. We will give it a delay of 10 units, and then we will use the display system task, and we will call it thread A. I will do the same for the thread B. Let's give it 20 time units, same as the previous video. So since we are using join none, the code flow will just continue and the process will not wait for any of the threads to finish first. So here, let's say there is a main process or the main thread right after the fork join block. So I will also write that inside a display system task. And since we have a delay of 10 time minutes for the thread A and a delay of 20 time minutes for the thread B, whenever the fork join is encountered, and since it's join none, which is non-blocking in nature, this particular display system task will execute and it will just display main thread finishes at time 0. So what if we have something, for example, if we have a dollar display here and it just says that all the threads have are finished. So we just want to display this after all the threads finishes. So since we are using fork join none, what could be the ways to do that? So we could simply just add a delay equivalent or more than the 30 time units, or it should be safe if we use more than 30 time units. But instead of that, we could use wait fork to make it wait for all the threads inside the fork join none to finish first. So the wait fork blocks the execution until all the threads spawned by the current process are complete. Even though we are using join none, the wait fork acts as a synchronization barrier. So let us use wait fork right here. So what will happen? Uh, the process will begin, and first the main thread will finish, and after that, at 10 units, thread A will finish. Then 10 time units later, thread B will finish, and after that only, when all the threads finishes, the display system task, which is written right here at line number 16, will print all threads or all the threads are finished. So it will block the flow till all the threads are finished. So let's see whether this works or not. So I will first compile the code. Okay, we do have some errors. Let's see. Uh, I think I should put it inside an initial begin block, an initial block. Yeah, it is running fine. So I will start the simulation. Let's run the simulation. So as you can see it right here, that as I have said, that the main thread will finish at time 0, and it did. Then the thread B finishes at time 10. The B finishes at time 20, and right after then, that only, right after all the threads or the process finishes in parallel, all the threads are finished. This particular system task, which is inside this display, prints. So even though we are not providing any delay of time units, this wait fork will block the execution or the flow of the code until all the threads finishes first. So that's how we can use wait fork. So there is another one which is disable fork, and for that we will do some modifications for this code. So suppose we want to have a scenario. Suppose we want to have a scenario in which if we start two threads in parallel, in our case, uh, there are two threads and the names are thread A and thread B. So if we start both of them in parallel and we want to create a code in such a way that If any of the threads finishes first, all the remainder of the threads will stop executing. In simple words, they will be deleted. They will be disabled. So, so we could use disable fork, and this is used to kill all the active threads. So whichever thread finishes first will unblock the main process, and then we can call the disable fork, which will kill any remaining active threads spawned by the current scope. So what I will do, uh, I will just write disable fork right here, and right after that, I will use dollar display system task just to indicate remaining threads are terminated. So as per the delay in time units, thread A is going to finish first, and since we also have to use join any. So as per the definition of join any, the flow of the code will continue and it will come out of the fork join block if any of the thread finishes. And if any of the thread finishes, we will encounter disable fork, and if we encounter disable fork, the remaining thread, which will be thread B in our case, will be terminated. And then this $display system task will be executed. So we can use it as a timeout. So it is a kind of an example which we could implement in our real life test bench, in which we will be running multiple sequences in parallel. So let's run the code without any further delay. Let's start the simulation. So as you can see it right here, that we did not see the display system task which is present inside the thread B. And right after, when the thread A finishes, the remaining thread, which is thread B, terminates. And the display system task at the end, that the remaining threads are terminated, is getting printed. So these were two process control which could be paired with fork join blocks. So I hope you find this video so useful, and please stay tuned for more. Thank you so much.